Welcome back to the AZ-104 exam prep series. This is Module 02, and we're tackling one of the most important and frequently tested topics in the entire exam, Azure Role-Based Access Control, or RBAC. If Module 1 was about who you are or the identity, this module is about what you can do, that is, authorization. Azure RBAC is the mechanism Azure uses to control who has access to which resources and what they can do with them. Today we'll cover the core concepts of RBAC and why it exists, built-in roles and what they allow, how to assign roles at different scopes, management groups, subscriptions, resource groups, and individual resources, how to read and interpret access assignments. This topic accounts for a significant portion of the Manage Azure Identities and Governance domain, which is about 20–25% of the exam, so pay close attention. First, let's question ourselves, what is Azure RBAC? Azure RBAC is the answer to the question, how does Azure decide if someone can do something? There are the three pillars that is the foundation to this question. Every role assignment in Azure involves exactly these three things. These are: Pillar 1, the who or the security principal. This is the identity being granted access. It can be a user, individual person, a group, collection of users, best practice to assign to groups, not individuals. A service principal, identity for an application. A managed identity, Azure managed identity for Azure services like VMs, functions. The next pillar is the role definition, or the what. This is a JSON document listing what the principal can do, or the actions, and what they cannot do, the not actions. And data plane operations like data actions or not data actions. Examples: owner, contributor, reader. We'll cover these in detail. The pillar 3, this is the scope or the where. This defines the boundary the role applies to. More on this next slide. Now here are some key behaviors to memorize. Additive model. If you have two role assignments that together grant permissions, you get all of them combined. Deny overrides. Allow. Azure Blueprints and Azure Policy can create deny assignments that override any role assignment. Deny always wins. Inheritance. A role assigned at subscription level automatically applies to all resource groups and resources inside that subscription. An important exam tip. The most common confusion is between Entra ID roles, like Global Admin, and Azure RBAC roles, like Owner. They are completely separate. Being a global admin does not make you an owner on subscriptions. Now let us look into Azure RBAC's scope hierarchy. The scope hierarchy is the most important concept in Azure RBAC. Understand this and the rest becomes easy. There are the 4 levels here, from broadest to narrowest. Level 1, management group. This is container for multiple subscriptions used in large enterprises to apply governance across many subscriptions at once. Role assigned here applies to all subscriptions, resource groups, and resources below. You can have up to 6 levels of management group nesting. Level 2, subscription. The primary billing unit in Azure. Everything in Azure lives inside a subscription. Role assigned at subscription level applies to all resource groups and resources inside. Level 3, resource group. Logical container for related resources. Best practice, group resources that share the same lifecycle, deploy together, delete together. Role assigned here applies to all resources inside that resource group. Level 4, resource. This is an individual Azure service, a specific VM or a specific storage account or a specific database. It is the most granular assignment level, only affects that one specific resource. Let's remember on key rule, inheritance. Permissions flow downward. Assigning a role at a higher scope means it's automatically inherited by everything below. You cannot block inheritance. If someone has owner at subscription level, they have owner on every resource group and resource within that subscription. An important exam scenario. A user should manage storage accounts in one resource group but not have any other access. The way is to assign the storage account contributor role at that specific resource group scope. Let us now check built-in roles, the big four. Azure has over 300 built-in roles, but their four are foundational and appear on virtually every exam scenario. These are owner. This is the most powerful role. Can do everything: create, delete, manage resources, and assign roles to other users. Best practice: only 2 to 4 people should be owners at subscription level. An owner at subscription scope has full control over everything in that subscription. Now let us look at the contributor role. It can do almost everything with resources, but cannot manage access. No RBAC role assignments. This is the role developers and operations teams typically get. The key distinction from owner: a contributor cannot add someone else as a contributor. Now let us look at the reader role. It is read-only access, can see everything but change nothing. Perfect for managers, executives, auditors, compliance teams. Viewers can't even see secrets like storage account keys; those require specific data roles. The final to look at is user access administrator role. It is a bit of unusual role, focused specifically on managing who has access, not on managing resources. Can assign roles to others, but cannot create or modify actual resources. Useful when you have a team that manages permissions, but shouldn't touch the resources themselves. Exam pattern. Watch for questions that try to trick you into picking owner when contributor is sufficient, violates least privilege, or questions where someone needs to grant access, requires owner or user access administrator, not contributor. Now let us consider role definitions inside the JSON file. Let's look at what's actually inside a role definition. This is important because the exam will test your understanding of how permissions are evaluated. A role definition is a JSON document with these key fields: actions, not actions, data actions, not data actions, and assignable scopes. Let's first consider actions, which is the control plane. It defines what management operations are permitted, uses a wildcard syntax like Microsoft. Storage/star means all operations under the storage resource provider. Star/read means read operations on all resource types. Now let's consider the not actions, which is the control plane exclusions. Note it is not a deny. It's a subtraction from actions. It removes specific operations from the allowed set. See that the contributor role has not actions for Microsoft .authorization/star/write and delete. This is exactly why contributors can't assign roles. Now let us consider the data actions. Note, this is important. Control plane actions and data plane data actions are separate. For example, Microsoft storage/storage accounts/blob services/containers/blobs/read is a data action that lets you read blob contents. Having the contributor role on a storage account does not automatically give you access to read blob data. You need the specific storage blob data reader data action for that. This is a common exam trap. Next, let's consider assignable scopes. Defines where this role can be applied. / means the role can be assigned anywhere in Azure. Custom roles can be scoped to specific subscriptions. How evaluation works. Effective access equals actions minus not actions plus data actions, not data actions. If you have multiple role assignments, Azure unions all the actions together, then subtracts the union of all not actions. Let us now see how to assign roles. Let's walk through the practical process of assigning a role. Three-step process. Step 1. Choose the scope. Navigate to where you want to grant access, the subscription, resource group, or specific resource. Next, in the Azure portal, every resource has an access control IAM blade in the left menu. This is where all role assignments for that scope are managed. Click Add, then Add Role Assignment. Step 2. Choose the role. You'll see a searchable list of all built-in roles. Microsoft has organized them into privileged administrator roles, owner, contributor, etc., and job function roles, storage blob data reader, virtual machine contributor, etc. Always review what the role can and cannot do before assigning it. Step 3. Choose the member. Search for the user, group, service principal, or managed identity. Here the best practice, assign to groups, not individuals. Here's why. Suppose the user leaves company, then remove from group makes the access automatically revoked across all role assignments. Now suppose a new user joins, add the new user to group, then the user immediately gets all appropriate access. Finally, this is easier to audit, one group to check, not scattered individual assignments. Assignment methods. Portal, the most common for one-off assignments. PowerShell, new as role assignment, great for scripted deployments. Azure CLI as a role assignment create, same as PowerShell, but CLI style. ARM, choke, bicep, templates, best for automated deployments. Role assignments become part of infrastructure as code. Now let us consider scope assignment examples. Let's look at a realistic scenario to cement the scope concept. Let us suppose Alice, who is owner at management group level. Alice needs to govern all of Contoso's Azure environment. Her owner role is assigned once at the top management group. This means she automatically has owner access to every subscription, resource group, and resource in the entire organization. Very powerful. Use carefully. Now we focus on dev team group. They would be contributor at subscription level. The development team needs to create and manage resources in the dev subscription. By assigning contributor to the whole dev team group at subscription scope, every member of that group can manage everything in the Contoso dev subscription. When a new dev joins, just add them to the group. They immediately get access. Let us now look at Bob, who is reader at resource group level. Bob is a project manager who needs to see the production web app's resources, but shouldn't be able to change anything. Assigning reader to Bob at the specific resource group scope means he can view everything in Arch Web App Prod, but can't modify or delete anything. He has no access to other resource groups. APP managed identity. Storage blob data reader at resource level. The application needs to read log files from a specific storage account. The managed identity gets the storage blob data reader role on just that one storage account. It cannot read blobs in any other storage account, and it cannot manage the storage account itself. This is the principle of least privilege perfectly applied. Key lesson: the narrower the scope, the more precise and secure the access. Let us now consider interpreting access assignments. This slide is about understanding what access a user actually has, which is often different from what you think they have. Let us consider the net evaluation process. Step 1, collect all assignments. A user might have direct assignments and inherited ones from parent scopes. You need to consider all of them. Step 2, union all actions. If role A allows Microsoft.compute/star and role B allows Microsoft storage/star, the effective set includes both. Step 3, subtract not actions. After combining all actions, subtract the combined not actions. Step 4, check for deny. If there's a deny assignment from Azure policy blueprints or an explicit deny, it overrides everything. Deny beats allow. Step 5. What's left is effective access. Let us consider a worked example. Sarah has reader at subscription level, inherited by everything below, and contributor at resource group level. Now, because RBAC is additive, union of permissions, contributor includes everything reader does, plus management operations. So Sarah's effective access on the VM is contributor. Note, important, there's no higher scope wins rule. More permissive access accumulates. If you have reader at subscription and owner at one resource, you have owner on that resource and reader everywhere else. How to check this in practice? 1. Go to the resource in the Azure portal. 2. Click Access Control IAM in the left menu. 3. Click Check Access tab. 4. Search for a user and it shows their effective role assignments at that scope. This is also how you diagnose why can't user X do Y. Deny assignments. Typically come from Azure blueprints or policy. They show up with a red circle, black slash icon, or the not permitted icon in the IAM blade. These cannot be removed directly. Must remove the blueprint or policy that created them. We now focus on custom roles. Custom roles let you define exactly which permissions a security principal gets, no more, no less. This is principle of least privilege in action. When to create custom roles. The most common reason, a built-in role gives too much access. For example, you want someone to be able to restart VMs but not create or delete them. The built-in virtual machine contributor lets them do all of that. So the solution is create a custom role with only Microsoft Compute / virtual machines / restart / action in its actions. When not to create custom roles. If a built-in role already does what you need, use it. Less complexity to manage. Don't create a custom role just to rename reader to viewing user. Unnecessary overhead. Some key limits. 5,000 custom roles maximum per Entra ID tenant. You must specify assignable scopes. This limits where the role can be used. Custom roles behave exactly like built-in roles once created. Now the creation methods. 1. Using Portal, intuitive wizard-based interface. 2. Using PowerShell, new as role definition, input file role, JSON. 3. Using Azure CLI as role definition create, role definition irole.json. 4. Using ARM template, Microsoft authorization, role definitions resource type. Finally, the lifecycle, modify, update the JSON and republish. Delete, cannot delete if there are existing role assignments using it. Replication, changes take up to 10 minutes to propagate globally. Relevant for time-sensitive exam scenarios. Manage identity and service principles. This slide is about the non-human identities in RBAC, which is increasingly important as everything gets automated. Managed identity. When an Azure service, like a VM or a function app, needs to access another Azure service, like Key Vault or storage, you use a managed identity. There are 2 types here. First, system assigned, created with the resource, deleted when the resource is deleted. 1.1 relationship. Next is user assigned, independent lifecycle. Create once, attached to multiple resources. Good when you have many resources that need the same access. The magic of managed identity. Azure handles the credentials entirely. There's no password or certificate you need to store, rotate, or worry about compromising. The identity is automatically renewed by Azure. Example flow. 1. Enable system-assigned managed identity on VM app 01. 2. Go to Key Vault, access control, IAM. 3. Assign Key Vault secrets user role to VM app 01's managed identity. 4. Code on the VM uses the Azure SDK to get a token, no credentials in code. Service principle. For external tools and pipelines that need Azure Access, GitHub Actions, Terraform, Azure DevOps, Jenkins, you create an app registration in Entra ID, which gives you a service principal, the application's identity. Then assign that SP a role on your Azure resources. Client secrets versus certificates. Client secret, basically a password with an expiry date. You must rotate it before expiry or access breaks. High operational burden. Certificate, more secure, considered best practice. Workload identity federation, the newest approach. GitHub Actions can directly federate with Entra ID, no secret needed. This is the future direction. Finally, an exam tip. If the scenario involves an Azure VM needs to read from Key Vault, use managed identity. If it's a GitHub Actions workflow needs to deploy resources, use service principal. Let us now consider some exam scenarios and gotchas. Let's work through the most commonly tested scenarios. 1. Deny override. This is a classic trap. User has contributor on the subscription that should give full access to everything inside. But if a specific resource or resource group has a deny assignment from an Azure policy or blueprint, that deny wins. Always check for denies when troubleshooting. Why can't this user do X? 2. Contributor versus owner for dev teams. The question is designed to see if you'll overprivilege. Dev teams need to manage resources but do not need to grant access to others. Contributor is correct. If you pick owner, you're violating least privilege. 3. Data plane access. This trips a lot of people. Having contributor on a storage account does not mean you can read blob contents. That's the data plane. You need storage blob data reader or storage blob data contributor for write, and assign it at the narrowest scope, the specific storage account. 4. Inheritance. Owner at management group flows down to everything. The exam will test whether you understand that one high-scope assignment grants access to everything below. This is why high-scope assignments need to be carefully governed. 5. Custom role for specific operation. When no built-in role fits exactly, create a custom role. The key for this example: only include restart action, not the broader virtual machine /star action. 6. Managed identity. The correct answer whenever an Azure service needs to access another Azure service without storing credentials is the key phrase in the question. Here is a summary rule set. Deny beats allow, always. Roles are additive, union of permissions. Inheritance flows downward, parent to child. Owner, contributor, plus RBAC management. Use managed identity for Azure to Azure auth. Let us now do a summary and wrap up. Excellent work making it through Module 02. RBAC is one of the most heavily tested areas in AZ-104 because it's fundamental to everything in Azure. Quick recap. 3 pillars. Every role assignment is the combination of WHO, security principle, what, role definition, and where, scope. All 3 are required. Scope hierarchy, management group, subscription, resource group, resource. Roles assigned at higher scopes are inherited by everything below. You cannot block this inheritance. The 4 key roles. Owner, everything including RBAC management. Contributor, poor everything except RBAC management, cannot assign roles. Reader, SHAC read-only. User access administrator, RBAC management only, cannot manage resources. Role definitions contain actions, not actions, data actions, effective access, the actions minus not actions. Control plane and data plane are separate. Access is additive. Combine all role assignments, then check for denies. Deny beats allow. Custom roles use when built-ins are too broad. Max 5,000 per tenant. Non-human identities. Managed identity for Azure services. Zero credential management. Service principles for external tools. What's next? Module 03 covers Azure policy and governance, how to enforce rules across your Azure environment at scale. This builds directly on the RBAC concepts we covered today, particularly around deny assignments and enforcement mechanisms. Action items before the next module. 1. Practice assigning roles in the Azure portal. 2. Use check access in IAM to verify effective permissions. 3. Try creating a custom role with restricted permissions. 4. Read the Microsoft documentation on RBAC role assignments. See you in the next module. Thanks.